Hi everybody, we're working on section 5.1, page 2. This is example 1b. We are given the function f of x is equal to 3 times x minus 1 to the 2/3 power, and we're asked to find the stationary and the singular points. Now if we remember, the stationary points are where the derivative is equal to 0, so f prime equal to 0, and the singular points are where the derivative does not exist. All right, for both of those, we're going to have to find the derivative. So let's start working on that. Our function is one function within another. So we're going to have to use the chain rule. We have that x minus 1 on the inside, and then the whole thing is raised to the 2/3 power. So that's our outer function. The 3 in front is the constant multiple, so we'll leave that alone for now, and just take the derivative of the outside, so bring the 2/3 to the front, leave the inside alone, and then subtract 1 from the exponent. So 2/3 minus 1 is negative 1/3. Then the derivative of the inside, so x minus 1, is just 1. All right, now the 3 on top and 3 on bottom will cancel. So we're left with a 2 that's on top. And then the x minus 1 has a negative exponent, so that's going to get dropped down, and we'll have a positive exponent once we drop it down. All right, now that we have our simplified derivative, we're going to find the stationary and singular points. The stationary point is where our derivative is 0, and the only way a fraction can be 0 is if the numerator is 0. So we're going to set our numerator equal to 0, which is 2. So 2 equals to 0, and we know 2 does not equal 0, that's for sure. And there's no variable in there, so there's no way we could possibly make that a true statement. This is never going to be true. So that tells us that the numerator will never be 0, which means there's no stationary points. If we head over to do the singular points, that's where the derivative does not exist. Our derivative is a fraction, and we know that if the denominator of a fraction is 0, it's undefined. So we're going to set the denominator of our derivative equal to 0. So x minus 1 to the 1/3 power, set it equal to 0, and we'll solve for x. So we're going to raise both sides to the 3rd power, because if you have a power raised to another power, you multiply. And 1/3 times 3 is 1, so we get x minus 1 to the 1st power, and 0 to the 3rd power is still 0. Now we're going to add 1 to both sides, and we'll get x is equal to 1. That's the x value where we have a singular point, but our question asks us to answer in coordinates. So we need to find the y value of our x coordinate. To do that, we're going to use our original function. Use the original function here. I can't emphasize that enough. So we're going to plug in 1 into our original function, f of 1. So we'll get 3, and then instead of x, we'll write 1 minus 1 to the 2/3 power. 3 times 1 minus 1 is 0, is equal to 0. So we have our y value. To summarize our answers, we already found that there's no stationary points. And our singular point, the x value was 1, and the y value is 0. So that gives us the point 1, 0. So we just found all of that by using the equation. Let's head over to the graph to see a visual representation of what we did. So on the left-hand side, you see that that's our original equation that we graphed. And there are no places on our graph that would have a horizontal tangent line. So that's why we didn't have any stationary points. But we do have a sharp corner or cusp at the point 1, 0, which we found in our previous work.